So the last piece of k-nearest neighbors is that I wanted to touch on some of the training and deployment issues in this algorithm. And so to train the k-nearest neighbors algorithm, there's actually no training phase. We just need to decide on a few hyperparameters. The first one, it's not even a hyperparameter, we just need to find a training data set. So we need to turn our training data into a set of feature vectors. And then we need to decide on what the value of k will be. And the number, k is the number of neighbors that we'll use for classification. And then we'll need to determine a distance metric that we'll use to compute the distance between records. So usually we use Euclidean distance, but as I mentioned earlier, there are multiple distance metrics that are sometimes used. And then to classify an unknown record, we'll compute the distance to all of the training instances, identify the k nearest neighbors, and then use the class labels of those nearest neighbors to determine the class label of the unknown or the new instance that we're classifying. For example, by taking the majority vote. So in kNN, there's really no training phase. Training the model just means deciding how we're going to represent our data, deciding on hyperparameters like distance function, the number of neighbors, and how we're going to weight the neighbors or whether we'll weight the neighbors. And as I mentioned before, kNNs are what's called non-parametric models and are sometimes called lazy learners because there's no learning, there's no training phase. On the other hand, the testing phase or the use phase means for every new instance that we want to classify, we have to compute the distance to every single training point and find the k with the smallest distance. So this means that kNN can be very inefficient if you have a large number of training instances because you have to compute the distance between every unknown, unlabeled instance and every single training instance if you really want to find the smallest k. So it can get very slow if you have a large number of training instances or a large number of features. And even in the homework assignment where you used kNN, I think you could see that the training time was really long for, or the model testing time was very long for the kNN model. And that was because for every validation instance, it had to compute the distance to every single training instance. So even with a few thousand training instances, that can be very time consuming. And so just a few remaining issues with kNN. The first one is, are kNN models intelligible or are they interpretable? And so for specific decisions, kNNs can be interpretable. Let's say for recommender systems, for example, this is a recommendation that was provided on my Goodreads account for me. It said, because you read this book, a similar book that you might like is this other book, right? I liked the book State of Wonder. Maybe I'll like this other book, Hunting and Gathering, because they're similar. And so in this case, specific decisions can be very interpretable. They're telling me this is why we think you'll like this other new book that you haven't read because it's similar to something you've read in the past. If we extended that to, let's say, explaining a decision about a mortgage application, and Mr. Smith comes in and applies for a mortgage and gets turned down, and he says, why did I get turned down for my mortgage? And the bank says, well, we turned you down because you're similar to Mrs. Brown, who defaulted on her mortgage. That is not a particularly satisfactory explanation to give to a bank customer. So whether kNN models are intelligible or not kind of depends on the context. It's also not easy to say what knowledge was learned from doing kNN. We can't really explain on what basis it's making the decisions that it's making compared to, say, a tree where we can say the important attributes that went into a decision, or especially in linear models where we can look at the coefficients and interpret them. And so there's not really an interpretable model that comes out of running kNN. kNN also comes with what's called the curse of dimensionality. If there's a large number of features or a large number of x variables, in this case, if all the neighbors are far away, it's sort of hard to find which ones are the closest. And so the number of training observations needed for kNNs to perform well grows exponentially with the dimensionality of the feature set. And so the curse of dimensionality is a big problem with kNNs as well. And then finally, there's this question of computational efficiency. kNNs are very fast to train. They're linear. They can be trained in linear time if you've done any sort of analysis of algorithms in the past, right? So they're fast to train. They have no training time, but they're very computationally inefficient in the test time. Right, the time required to compute a prediction for a new instance is much slower, and it grows with both the number of training instances and the number of features. So they're fast in the training time, slow in the test time. So in summary, the good things about kNNs is that they're simple to train. Right, there's no training really. We just decide hyperparameters. They're non-parametric models, and so they're very flexible. They don't make a lot of assumptions about the relationship between the x's and the y's. They can make highly interpretable decisions depending on the domain. And in the past, they've worked really well for recommender systems. So in the famous Netflix Prize contest, where teams were competing to improve Netflix's recommendation algorithm, the winning model ended up being an ensemble of kNN methods. The not so good thing about kNNs, they need a lot of data to perform well in high dimensions. On the other hand, if you have a lot of data in high dimensions, the time to compute is really high. And so there are some algorithmic advances in, removing redundant data, taking some mathematical shortcuts. So you can slightly speed up kNN's training or validation time. But in general, it's a lot slower than the other methods we've talked about. And then finally, the interpretability of the model is pretty questionable. And so just like all other models, kNNs are worth trying. They're worth experimenting with a wide varieties of k. There's no way of knowing ahead of time which model will be the best. So kNNs are just another tool in your toolkit for predictive modeling.